assuming everyone's got the communication about the school being closed down next week. So you have essentially like 2 weeks for spring break. What we're doing is we're basically moving this class to an online class. So keep the same schedule you normally would. Don't take on any additional responsibilities or extra shifts at work if it's going to conflict. So what's going to happen is I'm going to post lecture videos from last semester, which will accompany the blank notes, and then I'll also post the completed notes from last semester. They're virtually identical. Nothing major has changed. So that should get you a way to sort of quote unquote attend class, is to watch those lecture videos, and you can fill out those notes or look at those notes as you go along. So that's how we're going to supplement face-to-face instruction. So I don't think it's going to affect a whole lot on that end. I will end up getting rid of this specific link. Well, I'll keep this one, but I'll retitle it. These are the ones I keep here are the ones we actually did in class together, and then I'll post the remainder of the semester's lecture videos, and then that way you'll have access as if you were in class. Yeah, hold on.
What about the exam?
So the exams, we'll talk about that in a minute. The exams require a little more work.
I was going to ask, are you going to move over to the CCCO website? There's two down D2Ls, one for online and one for English class.
No, we're gonna keep everything the same. We're not like we're not like digitally moving anything to any other site. Like we're gonna communicate through D2L and emails if relevant, but nothing's moving to the CCCS. It's all gonna be here.
So the videos had obviously the audio, but then they also had the like the smart the thing
Right.
The stuff you wrote on the smartboard.
Yeah.
So we can follow on
They'll, yeah. The videos from last semester will be just like the videos from this semester, so you can follow along what I'm writing, what I'm saying. It might be weird because I'll be asking like, hey, do y'all have any questions? And somebody's going to be asking a question that you may or may not be able to hear. So there might be some weirdness to it, but it'll replace us being in class, but still be able to get the material as if we were in class. So at least we have that going for us. Otherwise, it would be a nightmare. As far as exams go, I haven't quite figured out how that's going to work, but we will do our exams on my math lab as well. So your quizzes and your homeworks, those aren't really affected, right? You do those like outside of class anyways. You'll continue to do those, but just like your quiz is timed and you get 2 attempts, our exams on MML will be timed and you'll have 1 attempt. Okay? So with that in place, you can go to Wolfram Alpha and you can type out integrate this problem or take the derivative of this problem, and it'll just spit out the right answer. So since we're moving our tests online to my math lab, you need to work out all of the test questions as if you were doing it in class, because somehow, some way, you're going to send your test to me. So like if my math lab says you got this one correct and your work doesn't support it, then I'll actually only credit you like 50% of the problem or whatever you missed. Okay? If you got it right on MML and your work supports it, then you get it right. But that's where I have to like go in and look at your work compared to what you entered and tweak it from there. So I basically have to grade based off of your work. The same stuff applies if you enter a period or a comma where it shouldn't be, and then on your test and it counts it wrong, then you just say, hey, I entered a comma or something, So like the standard rules of correcting syntax errors would apply still. Yeah. Sorry.
I was gonna say, so you know how like in my math lab sometimes it doesn't like if it's not simplified out of the way or something like that.
Yeah.
And you said on the test we don't have to.
Yeah.
How would we like be able to show you that we did? Just by like our work?
Your work, exactly. It's the key to submitting your tests online is going to be in your work that you submit to me. Because if my math lab wants a derivative completely simplified, but I don't, if you don't get the correct simplified version, but you have the derivative correct on the work you submit to me, I just go in there and give you a point for that or credit for that problem, and it's not counted wrong. Does that make sense? So like just because we're doing stuff online doesn't mean you can't show work. Like I'm still trying to figure out how the best way to do that, like whether it's take a picture on your phone. I know many of you probably don't have scanners that you can access. There's an app that works hand in hand with D2L called Pulse. They're supposed to be sending out information about that, where it's basically like you use your phone, you take a picture, and it uploads it to D2L. So I'm gonna have to figure out something. And that's really the biggest hurdle for us, because the other assignments are completed online anyways. It's just how do we supplement our exams? And I think the best option is to have you do them online, like a quiz, with one attempt. And I'll probably give you more than 2 hours and 15 minutes. I'll probably say everybody has 3 hours and 15 minutes to complete the exam, just so you can sort of get used to the technology, and it probably won't give you feedback on what you missed. So it's like you're sort of submitting it blindly along with your work, and really it's your work that's the main thing that's going to support your answers on the exam. Is everyone clear on that? I'm going to have to like type all of this stuff out, post it on D2L, because as I'm saying all of this stuff, it's there, but the details have to be hashed out. Yeah.
So for the exam, will it be like, is there like a specific time thing, like that we have to like take it in, or is
Yeah.
it like the quiz, like where like you completed like your attempt by like a certain like time?
Due date.
Yeah.
So the exams that are online, so like we have an exam on Tuesday. So the exam you take on MML will be on Tuesday. It'll start at class time. We're gonna try to keep things as normal as we can. So like on exam days, Tuesday for instance, we have an in-class exam, and you'll go online. The exam will open up at 1, and it'll close at 3:15. So again, just because we're moving stuff online doesn't mean you kind of do all this stuff as you go. The exam dates on the syllabus are going to be really firm as far as online submissions. And so getting that completed and submitting your work have to be done pretty close together. If you submit your exam the day of the exam, for instance, but you're not giving me your work until 3 days later, that's not going to count. So the exam dates are going to be as is. The times are going to be as we were taking them in class, with the addition that you have a little bit more time to complete since they are online. Yeah.
One thing, so next week classes are canceled, but
Right.
for us, would we still have to take the test on
Online.
Tuesday?
Yeah, because we're getting all of this information. Like if we had another meeting Friday, but after all this happened, then I would probably push it back. But I want to try to keep things as consistent with the schedule as we possibly can. That way, we're not all thrown off. So the exam is still going to be on Tuesday. Yeah,
So wait, is this applying to the rest of the semester, or is
Correct.
it just? Oh,
for all of the other exams, look at your syllabus, the schedule on the last page. So like Thursday, April 16th, we'll have our third exam, and that'll open on MML the same time class starts on that day. Final exams on the 7th of May, 1 p.m. You go on MML, it's open, you do your final exam. Yeah.
So what about for people who have learning accommodations? Is
So
that
I
also
can
going to
s-
transfer over to the?
Yeah, I can set by student. So like if you have an accommodation where you have extended time to take the exam, I'll just add that to what I'm giving everybody else. So like if everybody else is getting 3 hours and 15 minutes, then you're gonna get 5.5 hours.
Okay, and then what about technical difficulties? Because there's been a
Yeah.
couple times where my math lab has decided where if I click on a quiz, it opens and then it closes and then it counts it as a submission. So
Yeah,
what
then you just let me
happens
know
then?
and I can omit that.
Okay.
I can omit that attempt.
Just to make sure I understand it right, so we just have to start the quiz between like 1 and 3:15?
Yeah.
And then we'll have the 3 hours, 15 minutes?
Yeah,
Okay.
Right, well, yeah, so,
I'm saying, so like if I started at 2:30, I'm not gonna get cut out at 3:15 for my exam time?
yeah.
Like I would still have the full 3 hours and 15 minutes from the time I start it. I just have to start it in between the class time?
No, because I'll say like the exam starts on the whatever date the exam's on, start time, and there's going to be an end time, and if you don't have it done by the end time,
Okay,
That-
so
that's
it's
it.
It's a very specific window.
Right.
You'll start it at 1, if we have 3 hours, 15 minutes, it'll end at 4:15.
Yeah,
And then we just have to be there at
Right.
the computer at that time.
exactly. It's just like you were in class, like you wouldn't come to class at 3 o'clock and expect, 2 hours to take the exam, right? You got 15 minutes to take the exam because you came in late.
Right.
It's going to be the same thing with MML.
Okay,
Yeah,
gotcha.
yeah.
So I just want to get this. Oh wait.
Go for it.
Oh, okay. I just want to get this straight. So like for the rest of the semester, everything will be online then, right?
Correct.
Okay. So like we don't have to like. So then like we wouldn't like be coming to like this location.
No.
Okay.
That's the whole point of like all of your classes are trying to transition so people don't have to come to school.
What about math lab? Is that going to be closed down, or can we still come in if we want to?
As far as I know, they're going to restrict as much. Like, there's some people that have to come, like automotive tech, welding, people that have certain labs. But I wouldn't bank on like the school being open for just free use.
Okay.
So yeah, you might have to like, call a relative and see if they have a computer. I would assume that all of you have some sort of access because you've kept up with the homework till now. So somehow you're doing it. So yeah, if you have questions, just keep them up. Like,
So, so as you understand it, is that like pretty much guaranteed for this semester then? And then we'll reevaluate come the summer semester? Or the school will
yeah,
reevaluate?
that's as far as I've heard. Yeah, I don't think they've made any definite plans to say on this day everyone's coming back for this semester. As far as the summer goes, I have no idea. Yeah.
So kind of going back to the math lab question, so what happens if we need help on a math problem? I know that we can reach you in D2L or email, but for people like me who have to like see it, have it tangibly visualized,
Yeah.
can we still make appointments with you for help, or is this something where we should look for extra help outside of Front Range?
So what I'm attempting is WebEx, and everyone has access to WebEx. I'm not sure exactly on your end how you access it, but I believe all I have to do actually on my end is post a link. It's like a web address, and then you paste that web address to sort of join the chat room. And so it has like, you can type, you can do a voice if you have a mic at home. So like we could try to work through stuff that way. And again, some of these details I haven't hammered out. Like if I use WebEx, when am I going to be available? Ideally I could be available during class time and just say, hey, I'm going to be chilling at home on my computer with WebEx on. If y'all want to pop in with this link, pop in and ask me a question. Like that's probably the way I can supplement that. But I haven't fully explored those details. But I'm thinking that's going to be the easiest solution. Does that make sense?
Yeah.
Yeah, so we could you can totally chat, or we could, I don't have a document camera at home, so I couldn't in real time help write out the problem. I could write it out, take a picture or scan it to you. And we could try to, it's going to be a trial and error thing.
Okay.
Yeah.
So going off of that, are you going to be streaming the YouTube videos or the way for how you're going to teach us? Because the YouTube videos help, but that's because
Yeah.
it was live and you had that.
Yeah.
Do you have a way of already?
Yeah. I have last semester's
Oh, so we're just going to be watching
video.
that.
The downside to this is I title them by date. So if after our next exam, we're going to start 4.1 and 4.2. It's kind of a pain to find 4.1 and 4.2. You're just going to have to click around. So that, I mean, that playlist is already complete. That's the entire semester from, whenever to December. But yeah, all of that stuff is there. Like that was live in class at one point.
Yeah,
So when you
okay.
watch it, it's going to be like it's
Okay.
live in class. That's how we're going to supplement our instruction on that aspect. Anyways. Okay, so there's still other details to be figured out. Like I said, I'll like next week, faculty are going to be here, and we're all trying to figure out the game plan. So I'm going to communicate through D2L, primarily probably through these announcements or just through emails. So make sure you're mindful about that little thing up there. If I send out a class email, because that's where it'll go. It'll go here. Look for any. I'll retitle this and say this is our current semester's lecture videos, and then when I link to an actual completed set of lecture videos, it'll be this playlist here from last semester, fall 19. Again, you're just gonna have to sort of click through that. You can go by the schedule and say, all right, well we're 20 days into the semester. What's the 20th video? That'll probably give you the right kind of area. And then from where you start, you can determine where you should pick back up next time you visit the playlist or whatever. So yeah, as far as 3.11, we're gonna just cut that. So you still have your homework on 3.11, but I won't test you over it because we're not gonna finish the lecture. The other thing here is with these exam reviews. These all were pertaining to exams that I wrote myself. My math lab has limitations. I can't guarantee that my math lab test will have this many questions or would include like short answers and true falses. So that's going to be something else I have to figure out. Like I have to make the exams and then potentially post something like this or type something out that says, hey, exam 3 is going to have 10 questions, 5 of them will be this, 2 of them will be that, 1 of them will be this. So these exam content or this exam content, I don't know how accurate it's going to be since I have to type out or find questions online for these.
Do you think with this it won't affect our grade as much? Because maybe this doesn't work out and it affects our grade as a whole.
Yeah.
Is there a possibility of that happening?
I'm assuming so. Yeah, I don't know from an administrative standpoint, how this is going to work for them. Somebody's like, hey, I signed up for a face-to-face. My grade, I failed. I could totally see tons of people appealing their grades. But, basically, basically the only thing that's suffering for us is our in-class exams. That's basically the only thing that we've had to change. Assuming you're watching the lecture videos and filling out the notes, emailing me with questions, talking to me through WebEx, whatever, all of that's pretty much supplemented in a one-to-one. It's just the exams. But again, my math lab's super picky. That's why you send me your work. And I compare your work to my math lab, and I'm just going to be grading your exams on my math lab compared to your work. So that's the only difference. So in theory, we're not changing a whole lot, except for not being here in person. So hopefully your grade doesn't suffer. I would hope this transition's as smooth as it can be. Did you have a question?
Yeah, get back to me just for I forgot.
Okay. Yeah, go ahead.
Since you will be looking at the work submitted along with it, will you still be able to do the partial credit
Yes.
questions? Or
Yeah.
things like that?
Yeah, my math lab, when I go into fix your grade, it has me enter a numerical value. So if on your quiz, if you got the entire question right, then I just give you a point. But if you miss a negative, then I can give you 0.95 or 0.9. any sort of partial credit, I can give, even tenths of points, which I usually don't do, but it's very, very customizable as far as the amount of points I give you or don't give you. Yeah.
So for the exams in my math lab, are they gonna basically be questions that my math lab will pull, or are you gonna look at the exam and like pick and choose what questions we do, or are these gonna be questions where you've already looked at them and then you're gonna take the exam on my math lab, is it?
Yeah, so that's the thing, like the exams that I write, I've already worked the problems out. The ones on MML, I'm gonna have to pick through. I'm gonna have to work them out by hand again. I'm gonna see, do they actually work out nicely? And then put them into the test one by one, piece by piece. But yeah, it'll be the test on MML, I'll clearly mark, like in capital letters, test number, exam 2. It's just gonna be like a quiz, except for you've got one attempt and you've got a little bit longer time to complete it. Yeah.
So the exam that's coming up on Tuesday, it's still gonna be happening on Tuesday for sure?
Yes. Yeah. I don't wanna push anything back, because, in theory, most of your homework's done, and you're probably pretty prepared for the exam. Maybe not. Maybe you're going to take the weekend. You still have the weekend. So, yeah, we're going to try to keep it that way, because if we throw this exam off, then it pushes it closer to our third exam and to our final, so it starts to really cramp our schedule, I think.
So you'll just let us know over the weekend what method you want us to use for sending you the notes?
Maybe later than the weekend. Maybe Monday.
Okay.
Yeah.
But sometime before obviously sometime before the exam.
Yeah. So like when you're doing the tests on MML, like write them out first, do them by hand first, and enter your answer. That way, when you submit I can see when you submit your work, and then I can see when you send me an email. So there shouldn't be a huge disparity between those two times. In theory, you're taking that test like you're taking the test in class. That's just a podium to where you enter your answers, is more or less what it is. It's just a glorified enter my answers and let Cody grade it for me system. Yeah. Did you have a question?
Oh, I was just, because the technology thing, sometimes you'll like take a picture. Like for example, if we were to like take a picture of the paper, send it, the picture might not be very good, or
Yeah.
would you just like let us know to send in a?
I would, let you know to send it again. But if you're submitting by your camera, you preview that before you send it to me and make sure it's legible. Just to avoid that, because there's going to be I'm going to have to pull up one question at a time, one picture at a time, and go back and forth for every student in every one of my classes, and it's like the less things that I have to kind of do in that regard, the better it is for me. Yeah.
Just a note on that. I used to have one of these. There's notebooks on Amazon. They're not like regular notebooks. It's basically like a plastic notebook that you can write on with a special pen,
Mhm.
and then there's an app for that.
Yeah.
You can take a picture of the page and it'll make it into like an image document. Yes.
Okay.
I think it's like $45, something like that.
It's like just a smart notebook kind of thing.
Yeah, it's really useful, and
Okay.
especially in this case, it'd definitely be useful.
Okay. Yeah. If y'all are familiar with that, might be something to check out.
Alternative to that, there's an app for a phone called CS Scanner. They have one through Word as well. It will take the corners of the page, white it out, and it'll emphasize the black text.
Okay, what's it called?
CS Scanner.
CS and then scanner, or CS and ANNER?
And then Scanner.
Okay.
I'm pretty sure double check. And Windows Office has something like that as well.
Yeah, there's so many apps and things available. But yeah, I think the clearer you can take a picture of your work, the better it's going to be for all of us. Because then that way I don't have to is that a 2 or a -3 or what is that? And then I have to email you, hey, is that a 2 or -3? And then you have to email me back. Yeah. It's sort of flying by the seat of our pants at this point, but I think for most components for the course, we have in place, so we should be okay. It's just really those tests that are kind of iffy right now. Yeah. For this class anyways. I don't know how other classes are going to work out, but it's about as far as I've gotten so far in the last hour. So, so we can certainly talk about the exam. Based on this content, we can just build off of this. Any homework questions, other examples you want to see, that kind of stuff. Because we're still trying to prepare for our exam on Tuesday. Yeah.
Can you go over like a really quick review of the first units? Because like I remember like all of the rules and all of that, so it's gonna be like hard for me to use the super long way. Can you just go over that again?
Yeah. So like which ones specifically?
I didn't have a specific one.
There's a lot of units in chapter 3. The first we had 3.1, 3.2,
3.1 and
3.3.
3.2, like the ones when you have to use like we need to put x minus h or x plus
Oh,
h
the definition.
into the
Yeah. Okay.
in order to find like the thing before we actually got any of the derivative rules.
Okay.
'Cause
Yeah.
I forgot about that.
Sure.
I know you said that there would be like certain things provided for us, like on the exam. Will that still be like apply to the test that we're gonna be taking online now? So like certain definitions?
Certain definitions, no, there's really no way I can regulate that now.
Okay.
Like if the problem says use the definition of the derivative, you can look in your notes and see what the definition of the derivative is. As far as I know, there's not a way for me to like customize my math lab questions. Like there's
Okay.
test banks I could probably pull from, but I couldn't like go into a question and insert text and say, remember the definition of the derivative is this.
Okay.
There's no way for me to police any of that, to be honest. So like, hopefully, y'all are just as honest as you can be, as if we were taking the class, the test and class. But I'm an idealist, so.
No, I was just gonna say, yeah, like you said, you could just pull up a derivative calculator the same way. You could just, you could technically just look up what the reminder of a derivative definition is if you needed.
Yeah, exactly.
So there's not really.
Yeah, so you could look up what the definition of the derivative is, and if your derivative is right on MML, but you have like 0 work, then you get 0 points for that problem. Because most of your grade on the online tests are going to be based off of your work that you've sent me. So, yeah.
For like, I know for like, there's some things like, I don't remember which section it was, but like when it started first introducing like the power room or something like that, we kind of had to work it out at first, but now
Yeah.
we can kind of just like do it.
Right.
So are there going to be questions like that where it's like, there's not much work even required for the question?
Yeah, right. Some questions just don't require a lot of work. Like if it says find the derivative of 2 to the x, and you write 2 to the x ln 2, that's it, right? That's the derivative. That's all that's involved to take that derivative. So yeah, some things aren't really going to have work to show, but most things will. So yeah, I just kind of have to use your discretion. But again, you want to treat it like it's a class, like an in-class. So whatever you would write on an in-class exam to find the derivative of x squared, that's what you would write on your paper at home and send to me. Like even if it is like 5 steps when it really should be 1, that's totally fine.
So you know how in my math labs it kind of does a different description for it, like for like how it asks, from how like you ask it. What if we get confused with like how they're trying to ask a specific question and we don't understand how to solve it, what they're saying or how they say it?
Yeah, I don't know. Like what I could, again, the only other thing I can think about is being on WebEx during class time, and if something like that, if you're like in the middle of your exam, like you see like I don't understand what they want from me, then you just type or you speak and say, hey Cody, I don't know what question 5 is wanting. I think that's pretty much the only other solution that I have right now. Yeah.
I have a question about WebEx. Is that like basically like Discord where everybody can
Yeah.
join at the same time?
Right.
Or is it like one-on-one?
Yeah. You could do private chats on WebEx, like you can send a message only to me and I can reply only to you. But as far as I know, like if you start speaking, like everybody in the group can hear you. So it is like a Discord kind of thing, if you're familiar with that. As far as I know, I've never actually used WebEx. I know you can get it on your phone. There's an app on your phone. So on your end, you would just type in the address or paste the address, and then you should be in the chat room. Might have to like iron out some kinks, but that's how it's supposed to work. Yeah. Yeah, right. And if you don't have a mic, then you just type. I know this isn't ideal for anyone, but we're going to try to make the best of it and do what we can, and that's all we can do, right? Yeah, any other like logistics questions at this point? Like at some point I have to type up a document outlining all of this. And you all may be like, hey, what about that one thing in class you mentioned? I might totally forget stuff.
Have fun with that, though.
Yeah, yeah. Yeah, that's the administrative side of being a professional. All right. Well, if you think of anything as we're going, feel free to interrupt. I think we're just trying to carry on with a sense of normalcy here. Again, I don't know how accurate this content review is going to be anymore. I mean, the other option besides having y'all do them online is just take the paper tests and then email that to me. I don't know if that's better or not. I just somehow my mind just defaulted to online exams, but
Sure,
yeah.
I have a question. Can't you just add like an assignment on D2L? Like send us the paper one through online, or we can just print it out or something?
Yeah.
You can open like time period, like when we can tune it in
Mhm.
and then do that. instead
Yeah,
of-
yeah. I mean, that is another option. Like I have the exam written. It's on paper in theory. Just, we could figure out how to. I could try to figure out how to deliver that to y'all. Same thing would apply though. You got to take a picture of all your work and turn it in within a reasonable time frame, right? Can't be like, hey, here's a take-home exam. Just turn it in whenever you want. So I don't know. So even there could be some flexibility for how we administer the exams. I don't know. It's a lot to think about. This all just happened today, right? So, all right. Use the definition of the derivative to find f prime. I'll try the definition here. That's the definition. That's how you define a derivative for any function. So we need a function. Find the derivative of, I don't know. Find the derivative of f of x equals to, let me just do this, I don't know, the square root of, I haven't worked these out, so let's just see how this goes. Find the derivative of the square root of 2x plus 1 using the definition. Now, if you want to like check to have a sense of where you should be going, then just apply the our standard derivative rules to this. So this is just our check to make sure our work is going to be correct. So we have the function 2x plus 1 to the 1/2 power. And we're going to take the derivative, like with normal derivative rules, just as our check. So we have 1/2 times 2x plus 1 to the negative 1/2. That's the power rule on the outer function, times the derivative of the inner function. So that's going to give us the derivative that we come up with using the definition should be our 2x plus 1 to the negative 1/2, or 1 over the square root of 2x plus 1. That's our check. That's not our work. So we have to construct this difference quotient from the given function, and then we have to take the limit as h goes to 0 if we're using the definition of the derivative to do this. So we're going to say that our derivative, f prime, is equal to the limit as h approaches 0. Specifically now x plus h into our function, we're going to have the square root of 2 times that plus 1. So there's f of x plus h minus the given function. And then that's all over h. So then we need to simplify our difference quotient before we apply the limit. So I'm going to just take that off kind of to the side or down below as part of our side work to simplify this. So from here, we're going to just go down here. We're going to work on simplifying this expression. So we're going to just figure out, expand this. I mean, I guess you could leave it if you wanted, but we have 2x plus 2h plus 1 under that first radical, minus the square root of 2x plus 1 all over h. Maybe I should have wrote all this down here. That's a 1. Okay. So keeping in mind that we've got to get that h out of the bottom because h is approaching 0 in the limit, which is giving us the issue. So we've got to somehow simplify this. What technique is involved in simplifying something like that?
Conjugate?
Yeah, the conjugate. The conjugate of the top. So we're going to say, let's multiply both top and bottom of our difference quotient by the square root of 2x plus 2h plus 1 plus the square root of 2x plus 1. Top and bottom by that. So that's the conjugate of our numerator. We simply just change the operation between the two terms. Do y'all remember that? I've done that a handful of times at least. So the h in the bottom is what we're trying to get rid of. So again, don't multiply your h in the bottom, try to simplify that. Just leave your h in the bottom times all of the conjugate. What happens to the numerator when we FOIL that out or expand it? Yeah, it takes away the square root. So like the square root of 2x plus 2h plus 1 times itself is just 2x plus 2h plus 1. And then what else do we have?
Plus 2x plus 1.
Plus 2x plus 1? What do y'all think?
Minus.
Yeah. Should be minus, but it's minus 2x plus 1 like this.
In parentheses.
Yeah, in parentheses, right? Because we're subtracting that quantity off. And again, here's what this boils down to. All of this stuff here is A minus all of this stuff here is B. We're multiplying that times, again, A plus B. And when we multiply that together, we just get A squared minus B squared. So there's our A squared, undoes that radical, minus there's our B squared, undoes that radical. Okay. And then all of this is over H times our conjugate. Then we're just going to combine our like terms on top. So we have a 2x minus a 2x, and we have 1 minus 1, right? Because this has to go in here. So that just leaves us with our, leaves us with our 2h on top, h here, times our conjugate. Is everybody okay with that? So you're now at this point that you see that the h's divide out. So that's sort of our last step before we then put this back up to where we were taking the limit. So we've got 2 over that conjugate. Okay. So the only other thing we need to do now is apply the limit as h goes to 0. Limit as h approaches 0 on this function of 2 over 2x plus 2h plus 1. Plus root 2x plus 1. What happens as h goes to 0? What do we get with our simplified difference quotient? That's 0. So we have 2 over the square root of 2x plus 1 plus the square root of 2x plus 1. Yeah? So since you've got 2 of those on the bottom, you get 1 of those, or those 2's divide out rather. So according to the definition, that should be the derivative. According to our derivative rule quick check, that's what the derivative is. So at that point, we're like, yeah, we did it right. If it didn't match, then more than likely you did something wrong. And you'd have to just go back through this work right here to see where did I mess up. But you can certainly check using derivative rules. And for any other question, it's going to just say find the derivative, right? Like this one specifically says find the derivative by using the definition, which is why we went this limit route. Any other derivative that shows up, you're just going to product rule, chain rule, quotient rule, whatever. Right? Is everyone clear on that? I've given like really complicated functions, like a product and a chain rule, and people on the exam want to take all derivatives with this limit. You don't have to do that. There's only one instance possibly where you have to take the derivative using this limit. Yeah.
So you said previously that like for those derivatives that have like multiple like derivative rules within them, like that, like this was like before, like when you said that it would be on like a paper exam, that it would go up to like, it would have like up to 3, I guess. But like on D2L, like it's sometimes like, especially the homework problems, sometimes they have like a lot more steps than like 3 derivative rules. So
Yeah.
would you like keep it down to like around 3 or so, or
Yeah.
would, like some of them have to be like really long?
Yeah, I'm gonna try to, if we do tests on MML, I'm gonna try to keep them as close to the exam questions that I have. Just so that there's not any inconsistencies with what we've done in class versus what you have to do online potentially. Yeah. But again, I don't know, maybe there's an option where I can just send you the exam. You can work it and scan it or somehow and send it back to me. I think if that's the case, so like the other option would be for me to email all of you and say, here's the exam, please have it turned into me no later by whatever. It means you're gonna work the exam, take a picture, send it to me by 5 p.m. or whatever that deadline is, as opposed to just like entering your stuff online. So I don't know, to me there's not really a huge difference between the 2 methods, but I'll have to think about it a little more. I think honestly for me it would be easier to just send you the exam I already have written as opposed to trying to make another test on my math lab. But I'll keep you updated. Yeah.
Oh, I was just wondering, like, would there be an option to do either or? Because I would prefer like printing it out and like if you sent the exam just
Right.
for me, because like writing it myself is just easier, like having the physical exam.
Sure.
Than doing it through the computer. But I know like some people would rather do it through the computer. So.
Yeah. So there might be settings, because like when you take a quiz, you don't have an option to print it, and if we did exams online, it would be just like a quiz, right? You don't have that option to print
Yeah.
it, and that might be something I could change. I don't know.
Okay.
I've never looked that far into it, to be honest. Yeah, so I don't know. We've got options, which is good, I guess. Okay. Is there other things that y'all want to look at? Yeah.
3.9. Just the kind of some of the lessons of 3.9.
So that was logarithmic
Yeah.
and exponential logarithm derivatives. I guess I can go here. So was it logarithmic differentiation specifically you want to look
Yeah.
at? Yeah.
So, you know, for 3.10, I believe it was, with the invert, or the, you said that would just be matching.
Yeah.
Is that something that we'll still be able to do online, or it'll probably come up with some problem as to?
That would probably come up with something, yeah. So,
But like the 3.10 homework.
yeah, and if that's the case, then I just wouldn't have those on there.
Oh.
Because I told y'all that the inverse trig functions would just be matching. If I can't do that online, if I can't figure out how to do a matching question, which I don't think they have, then I would just take that off. But the more I think about it, the more I'm leaning to just emailing you the paper exam. Since it's already made and we've already said, this is what's gonna be on it. That way we don't have to like change too much.
Are you still gonna take 3.11 off?
Yeah. Yeah, there's still no 3.11 because we didn't finish the lecture in class. I don't know if we'll have time, but I figured we should at least address the elephant in the room before we just jumped right into math. I mean, any one of these we can really do logarithmic differentiation on.
Say 36.
36. So what I was thinking, like, for as far as the exam was, its functions more like this, or it's like g f to the g or whatever. So let's do. Can we do that one? Let's do x to the square root of x, and maybe we can do another one if y'all want. So we would want to use logarithmic differentiation to find y prime, given y is the, well, I don't know, is that too basic for y'all, or do y'all want to see that? No?
You should do a trig.
Okay, let's make it a little more involved. We kind of did one like this in our homework. So, how about x to the cosine x?
That'll work.
Okay. Okay, let's use logarithmic differentiation. So we have, we're going to apply the natural log to both sides of our equation. And then remember, before you take the derivative, you want to simplify as much as you can with properties of logarithms. So we're leaving natural log of y alone, and we're just going to simplify algebraically the right-hand side. Power of the logarithm can come out to multiply. And since at this point there's no other simplification to be done, then at that point is when you take the derivative of both sides. So we have the derivative of ln of y would give us what? Y prime over y. Implicit differentiation using the chain rule. So remember, just as a general thing, the derivative of the natural log of something is 1 over that thing times the derivative of that thing. So we have 1 over y times the derivative of y. We just put that up top. Right-hand side needs to be, the derivative needs to be taken using the product rule. So we have the first times the derivative of the second plus the second times the derivative of the first. Derivative of cosine is minus sine. So I'm just going to rewrite that side. So we have the cosine of x over x. And then we have minus, however we're going to write that, ln times sine. Chain rule gives us the derivative of the right-hand side, or sorry, the product rule, and then we solve for y, because we want to, or solve for y prime here, because we want to know what the derivative is. So last step with implicit is always solving for the derivative y prime. So we're just multiplying through by y, right? Y here to cancel with this y, and that means we're going to multiply all of this by y as well. our derivative. And like on the exam, I wouldn't expect you to simplify these. Any of the logarithmic derivatives, as whatever you have on the right-hand side, just multiply it by y. But, you know, don't leave it like this. Don't leave it like that. Just actually put in what y was in terms of x, because we want the derivative with respect to x. So don't leave the y there. Just put that's all you would have to do on any logarithmic derivative. I don't expect you to ever multiply that all the way out and try to simplify it. Does anyone have any questions?
Why did where did the natural effects come back?
Here?
Yes.
So that was part of the chain rule, or the product rule, when we said it's the first times the derivative of the second, it went away. But then we have the second times the derivative of the first.
I see.
So it's staying there, because it's the second factor.
Okay.
Can you do something from 3.6?
Okay. Yeah. Any other questions on the logarithmic derivative? So from 3.6. I'll leave that in case there's other. That one has a few parts to it, so look at that one. Sorry, some technical difficulties here. So this is from 3.6, where we looked at a bit like an application of the derivative. And so we're given a position function, s of t. We want to answer some questions about it. So if you want to take a moment to write that down. I can just write one part at a time. We really just need this position function. And part A says determine the velocity v of the stone after t seconds. So in part A, what is it asking us to find? Yeah, the velocity. It's just saying determine the velocity after t seconds. It's arbitrary. It wants us to find the velocity function v of t. So from position, how do we get to velocity? You take the derivative of position. So we're going to take the derivative of s of t. So s prime is v of t. Plus 32. Derivative of 32t is 32. Derivative of 48 is 0. Okay, so that's all part A wants. What's the velocity after any time? It's that. Part B, when does the stone reach its highest point? Part C, what is the highest point? So basically part B and part C are depending on your process, could be part of the same process. But sort of the natural progression of this problem is it says determine the velocity. Then it says when does the stone reach its highest point? So how would we find part B? When does the stone reach its highest point? What do we need to do?
Equal to 0.
Set the velocity equal to 0, right? And that's particularly accurate here because our function is a negative quadratic. When does it reach its highest point? Well, it's right here. So that's the vertex of our parabola, or it's where the tangent line, the derivative, is 0, horizontal. Taking v of t, or the derivative of the function, and setting it equal to 0 to find a maximum or a minimum is something that we do in chapter 4. So not only does it apply to quadratics, but if you had a function like that, then determining where the maximum is, it's the same process. Here, it's not a quadratic, so we can't say find the vertex, right? The process of where is my tangent line horizontal still works, however. So I think it's I don't know that it's better. It's just an approach that applies to all functions, not just a quadratic. So where is the velocity 0? We've got to figure out when does negative 32t plus 32 equal to 0. That's a pretty straightforward thing to solve when t equals 1. So that really answers part B. When, what time does the stone reach its highest point? After 1 second. T is measured in seconds. Or at. We should say at, not after. Highest point is reached at 1 second. Answer to part B. And then part C wants us to determine what is the height of the stone at the highest point? What's its maximum height? So we take our T we just found in part B and do what with it? Plug it into the position, because the position's outputting the height. So for part C, we're going to take that, and we're going to take this 1 right here and plug that into position. So part C says, what is S of 1? That's what it's asking. I think that was right. Go back to it, make sure. And our position function is measured in feet. So we have whatever that is, I don't know, 16. 16 and 48. So the time it takes to reach its maximum height was 1 second. The maximum height actually reached is 64 feet. Part D asked, when does the stone strike the ground? So part D, when does the stone strike the ground? What are we looking for in part D? Yeah, come in.
We have to set the position equal to 0. Is that right?
Yeah.
Is it? Okay.
That's right. So the situation is that this stone is thrown from somewhere that's 48 feet above the ground. So here's something that's 48 feet above the ground. The stone's being thrown off. We want to know, when does it hit the ground? It's all a matter of how you sort of visualize this in the plane, right? We might as well consider the cliff to be up here at 48 and say that then the ground corresponds to the t-intercept, or 0, right? I don't know. Maybe you're envisioning this thing like up here at 100. I don't know why you would, but then the ground would be somewhere over here, right? Because the thing's 48 feet high. So hopefully you're envisioning it how it really makes sense. I guess there's a lot of ways to picture it. We can envision it being sideways or below the axis, but the ground in these problems is going to correspond to a position of 0. That's how they're set up. Okay, so we've got to figure out when the position is 0. And notice that's going to give us when, because we've got to solve when the position function is 0. We're solving for t, which gives us a time, which is a when question. So we want to know, when does this equation, or for what t values is this equation 0, or this function 0? We could factor out a 16, or a negative 16, doesn't matter. So then we just really need to solve when the quadratic negative t squared plus 2t plus 3, or when t squared minus 2t minus 3 is 0. Should be able to factor that, I believe. Factors of 3 that add to get, or sorry, factors of negative 3 that add to get negative 2. Can we factor that? Yeah. So that gives us 2 t values. T is 3 or negative 1. So the time it takes to reach the ground is 3 seconds, yeah. And we're assuming when we say at 3 seconds, at 1 second, we mean 1 second after the thing's thrown, 3 seconds after it's thrown.
Would there always be like a positive and a negative? Or would it be like an instance where it's like a positive and then both positives? Which one would make better sense?
Yeah.
Because like on this one, we know it's negative, so we can just cross that one out.
Mhm.
But when if it's two positives, when would we know which one to pick? Or is it like both? Or-
So yeah, you shouldn't get 2 positives here. The problem should be set up to where either you get 1 positive or 1 positive and a negative, so you can throw out the negative. You know, because you throw an object to the ground, it's going to hit the ground once.
But what if it bounces?
Yeah, that's for a later class then. Like, what happens if it keeps bouncing? You've got other variables and parameters you've got to factor in, like air resistance and friction. Yeah.
But for this class, there's always going to
Right.
be something like that.
If you get 2 positives, you probably did something wrong. Okay, and then the next part is built off of this. So just keep in mind, the question, they might not, the question on the exam might not ask when does it hit the ground and with what velocity does it hit the ground. It might just ask one of those. The way this question is built and structured is it sort of forces you to find one thing before you find the other. So it is kind of layering the question in a step-by-step basis, but question B could have been omitted and question D could have been omitted. We still could have answered C and E in the same way, right? Like we said in class, the questions about position, velocity, and acceleration, they're all functions of time. So if you want to know, hey, what's the acceleration? What's the acceleration when the sun's going around the moon? You've got to figure out what time that happens before you know the acceleration, because they're all functions of time. You always have to find the time in which a specific event takes place before you can say anything about position, velocity, or acceleration. So part E, with what velocity does the stone strike the ground? Well, that process by itself is this process in part D, and then plugging into the velocity. So if we didn't have part D and it says, with what velocity does the stone strike the ground, you have to do part D anyways. Whether it's stated that you have to do it or not. There's no other way around it. So the bulk of the work for part E, with what velocity does the stone strike the ground, the bulk of that work's already done in the previous question. So all we have to do is figure out what's the velocity when it hits the ground at 3 seconds. What's the velocity? Let me answer that question. Oops. Just kidding. That T is now 3. So what do we get? What are the units for the velocity in this situation?
Seconds per feet per second.
Yeah, feet. Position in feet, time in seconds. Position over time is velocity.
Would the negative imply that it's like coming to a stop, right? Or
So yeah, what does the negative mean?
It's falling
It's
down.
going down.
It means it's just falling down. It hits the ground in with a downward trajectory, if you will.
so okay. So what about like this? Say for like a car crashes into something, it stops at a velocity also. Is that something almost like this, or is that completely different?
Like if you're saying what's the velocity of the car when it hits the wall?
Yeah, or like at what velocity does it stop? Because like it comes to a stop, doesn't it? The negative force. I'm like thinking too much into it.
I would say when it comes to a stop, the velocity is 0.
Yeah, but like at what rate is it stopping?
Oh.
Because it doesn't just completely stop. It's like it takes time for it to stop.
Yeah.
Isn't that like how cars like for crashing? That's how they do it safely.
Yeah. Probably, I'm not quite sure. I think that's sort of a relative motion kind of thing, because you've got a velocity at impact, and then you've got the force of the wall acting on the car,
Yeah, that's
which
right.
sort of pulls it back. So that's like I think we'd have to relate the rates. I don't know what the physics equation is though to relate the rates.
Because it's not.
Yeah, it's kind of the same, because we say the car strikes the wall at a velocity of 64 feet per second. But what happens after that?
Yeah.
We have to do other stuff, yeah. Okay, so negative indicates direction down. And then on what intervals is the speed increasing? So some interval or intervals speed is increasing. How do we find what is speed defined as? The absolute value of velocity. Which is the absolute value of negative 32t plus 32. And again, we don't want to think about it that way. If you know what the absolute value graph is, you could say, all right, well, what transformations are applied to get this graph? What we want to think about is, here's the velocity. And we're starting at 0, so at 0, this thing's going to be here at 32. And then we have this negative slope, like that. That's not good. Pretty large negative slope. I don't know if the original problem told us a stopping time. I would assume not. So, we would just continue on in that direction. Here's our initial velocity. And so I think that makes the question about speed a little bit easier, because speed, since it's the absolute value, we'll still be up here at 32. There's that, whatever that intercept is. And then this other piece here that's below the axis just gets made positive, so now it's up here like this. So then we can see that, all right, well, speed's decreasing from 0 to this intercept, and then it's increasing after the intercept. So we just got to figure out the intercept for the velocity function. What would this intercept be? Yeah, we've already found that, right? When does velocity equal 0? Here's our velocity function. When is it equal to 0? When t is equal to 1. So that's 1 as well. It's increasing. And I don't know if the original problem specified an interval. I don't think it did. I don't think it said on the time interval from 0 to 25 or anything like that. If it did, then we can refine our answer, but I don't remember it saying that. Yeah, I mean, we'll just assume that it continues because we weren't giving a stopping time. So we'll just assume it continues. Okay. So if it says find the velocity at which something strikes the ground, you've got to figure out when the position's 0, find that time, then plug it into the velocity. Any other questions about this type of problem? I think we'll take a break and continue after. So do y'all want to look at other stuff? Other concepts?
Yeah, it's like the one where it's like the multiple derivative rules inside the chain rule, I think. Or it's the ones like where you have to do them 3 times.
Yeah.
Something like that.
Okay. Some of those look pretty gnarly.
Let's do 54.
54, all right, yeah, looks cool. Okay, so our function is sine squared of e to the 3x minus 1. So I think it's more conducive to view this function as the sine of the quantity e to the 3x minus 1 power. And then all of this is squared because it's sine squared. Right? Just like when we write sine squared of x, what we mean is sine of x squared. Okay, so definitely a chain rule. We only see like this occurrence of x in the power of e. So it's not a product rule. We've got the sine of e of 3x minus 1. So when we take the derivative, we say, well, what's the derivative of the outer function? And we leave the inner function alone. So here with y, what's the outer function? What's the outermost function? The square, right? The sine's still on the inside of that square. So we're going to take the derivative of the outer function and leave that inner function alone. To the first, we don't necessarily have to write that, but there's the derivative of the outer function, leaving the inner function alone. And you know, I don't know, let's put parentheses though so we're clear. We're taking the sine of that quantity. Okay, so the derivative of the outer, leaving the inner alone. Are we done? No. We have to do what? Multiply by the derivative of what? The whole inside function here, the derivative of all of this stuff. Okay, is everybody all right with that? Our function involved the chain rule, we've applied the chain rule. So any subsequent derivatives that show up, we're just going to treat that as almost like a separate problem. We just have to fill in for the derivatives. So we'll take this derivative and calculate it somewhere else. We'll go over here, take the derivative of the sine of e to the 3x minus 1. So it is, in effect, we're starting over because this is another chain rule. So we take the derivative of the outer. What's the derivative of the outer function here? Cosine. The derivative of sine is cosine. Leaving the inner function alone. So that's still the e to the 3x minus 1. Are we done with that? No, we have to multiply by the derivative of... Yeah, the inner function now is e to the 3x minus 1. I don't know how you want to view that. We've got to multiply by this derivative here. So I don't know, we'll start over again because there's another derivative. So we go down here, calculate the derivative of e to the power of 3x minus 1. What's the derivative of e to the 3x minus 1? We do remember the derivative of e to any power, it's still the chain rule that you apply to it, but I think it's easier to think about the derivative of e to any power is e to that power times the derivative of the power, right? You take the derivative of the outer function, e to a power is still e, leaving the inner function alone, multiplied by the derivative of the inner function. So, e to the power times the derivative of the power. That's how we take the derivative of e to any function of x. So we have the derivative of 3x minus 1 is just 3. Okay, so there's no derivatives left in this one. We're done with that little derivative. We come back here and insert it into this derivative. So we have the cosine of the quantity, e to the 3x minus 1, times the derivative of e to the 3x minus 1. No more derivatives left there, so that must be the derivative of the sine of e to the 3x minus 1. Does anyone have any questions? Yeah.
For something like this, can we also use like the natural log?
Yeah, logarithmic differentiation. We could try that next.
In the test, would you say like use the chain rule in order to do this? Or
I would just, like something like this would just say find the derivative. Yeah, and if you wanted to use logarithmic differentiation, yeah. So on the paper exam, I only have like one question that says use logarithmic differentiation to find the derivative. Any other derivatives you find by whatever rule you want to find. So like if I said find the derivative of, x squared and you wanted to use logarithmic differentiation on that, you totally can. So we've got to put that in place of this. The derivative of this stuff right here was cosine of e to the 3x minus 1 times 3 times e to the 3x minus 1. And then we still had all this stuff here, 2 times the sine of e to the 3x minus 1.
So you took the derivative of the right side, but were you still going to take the derivative of the left side? Or?
If we had logarithmics differentiation, yeah, we would have ln of y over here, but we just apply the chain rule. So we took the derivative of y as y prime.
Okay.
Yeah. Thank you. Cool. Okay, so that's your derivative. That's our y prime. I'll just leave that stuff there. Does anyone have any other questions on that? That was 3 chain rules. One was here with the derivative of sine of e to the 3x minus 1. Well, actually, the first one was just a application to the squaring function. The second chain rule came in to find the derivative of sine of e to the 3x minus 1. And then we had this green chain rule again. So that was our third chain rule. There's actually 4 in here, really, because we had another derivative show up. Okay. So can we do this one via logarithmic differentiation? I think, we can, but whether it's going to simplify all that much, probably not. We can certainly try. So that's squared. We took the natural log of that, so let's write it like this. Well, I had the brackets in a different spot. So it doesn't matter how you denote it. I'm just going to use our brackets so we're consistent. We're going to have brackets around that for the square. But we are taking the natural log of all of that. Okay. So the only thing we can do here is to simplify the power. We've got the natural log of something raised to the second power. That second power comes out to multiply this logarithm. So unfortunately, with like multiple compositions of functions, the logarithmic differentiation in a lot of cases doesn't really allow us to break the function down further, because we're dealing with the log of a single function on the inside. If it were like the sine of x plus or times e to the 3x minus 1, then we could keep breaking it down with logarithms. If it were sine of x divided by e to the 3x minus 1, but we're stuck at this point. That's as far as we can go with logarithms because it's the log of this function. It's not something times something else. It's not something divided by something else. That's it. So from here, we would take the derivative of both sides. We're not going to take the derivative of 2 because it's the constant multiplying that function. So it's 2 times the derivative of the natural log of sine. So how do we take the derivative of the natural log of this function? Well, we do 1 over the argument. And upstairs we have the times the derivative of the argument, right? Y prime over y, or derivative over the derivative. Or sorry, derivative over function. So at this point, you should probably stop and say, well, isn't that the original function I have right there? Right, take the derivative of sine of e to the 3x minus 1. It's pretty much the same as the original function, except for it's not squared. I mean, we can totally continue, but I think at this point you should realize, well, it really didn't improve my situation much, because I still have to take the derivative of this thing here anyways. Right? And we did that just fine with the chain rule, but then we have to divide it by sine of e to the 3x minus 1, then we got to multiply it by 2, then we got to multiply all of that by y. It's a lot more convoluted. So I don't know, you can continue with that one, but I would certainly stop there and abandon that process. If you continued, you should get the same exact thing that we ended up with, right? It's not that there's something wrong with this, it's just that it's not terribly efficient. Okay. Does that make sense? Do you have any questions or comments about that? So yeah, if you've got multiple chain rules, 2, 3 chain, or 3, 4 chain rules involved, logarithmic differentiation is probably not going to help that much. Yeah, some of these are just too much. You had one like this on your homework. I don't But yeah, is there any other of these chain rules anyone wants to see or work through? If you can see that very well. Still kind of blurry, huh?
So if we do some using the derivative of trig functions, but not ones that are like sine or cosine, like ones that we have exactly used a whole lot of.
Like which ones?
Like, I don't know, secant or cosecant or something like that.
With like other than just like secant x and tangent x?
Well, stuff like that, or just, there's something where we have to find the derivative of secant x or cotangent x or cosecant or something like that. Because I know in the homework a lot of it makes us use a lot of like sine or cosine, so we kind of used to that, but
Yeah.
something that we don't see a lot of in the homework.
Yeah, so like, those, tangent, what do we have? Tangent, secant, cosecant, etc. To take the derivative of something like y equals tangent x versus y equals to the tangent of the square root of 2x plus 1. There's really not a lot of difference other than the chain rule. So like if you know, all right, well I'm taking the tangent of the square root of 2x plus 1, I have to take the derivative of the outside, which is tangent, leave the inside alone, and then multiply by the derivative of the inside. You kind of get rid of those trig functions with like one step. But yeah, what is the derivative of tangent? Does anybody remember? Secant squared is the derivative of tangent. So if we take the derivative of the tangent of the square root of 2x plus 1, we say, well, the derivative of the outer function tangent is secant squared. And here we're leaving the inside function alone. We have to multiply by the derivative of the inside. That's really the main thing to be aware of with trig functions is what just as like an outer function, what is its derivative? I don't know if that helps or not, but everything else is a chain rule.
That's something similar to this. What about like the inverses? Are you gonna have those on the test too?
Yeah, if the inverses show up, depends on how the test is. If the test is on paper that I emailed to you, then yeah, the inverse trig functions will be there as matching problems. Match the function with its derivative, kind of thing. But if it's online, then I can't really do that. So it kind of depends at this point.
Like by
You should know the derivatives of the inverse trig functions, though, for sure. Especially those of you that have to go on to Calc 2. They come up frequently.
By matching, do you just mean like take the derivative of cosine, inverse of cosine, and match it with the true statement, right?
Yeah,
Okay.
exactly. So it's like here's the function. You have all your inverse trig functions here.
Oh, okay.
And then over here you would have derivatives.
Do we now like use those in Calc 1? Is it just like for Calc 2, like we actually get to work with them?
Well, they show up in various regards in Calc 2, but yeah. You need to know them to some extent. So yeah, then you would say, well, all right, inverse sine's derivative, that's this one. I might have like, this is A and this is your capital D, and then you would just put, this in place instead of drawing an arrow to it. So that's all that I mean by matching. So yeah, if you know these derivatives here, then if they show up in any other variation, in theory, you know how to take the derivatives because we're just looking at the derivative of the outer function. What's the derivative of secant? Secant tangent. Times tangent, yeah. secant times tangent. You know, so that's really the main idea that you should focus on. Because as you're going through other derivative rules, you're practicing those. And if a trig function is thrown in there, you know how to take its derivative. So cosecant derivative. So, you know, the ones with secant and cosecant are kind of weird because they have two trig functions. But that what we're seeing is that's how you take the derivative of the function of the outer function when the outer function is secant or when the outer function is cosecant. So just to kind of illustrate that. If it said, I don't know, like let's say y was the secant of the square root of e to the x squared. Something like that. So really a lot of these, it boils down to what kind of function is this? This function is a composition. It's the secant of another function. So it's the chain rule, and we have to take the derivative of the outer. So the derivative of the outer function, and you leave the inner function alone, right? So the derivative of secant is secant tangent. But in this step of the chain rule, we have to leave this inner function alone. So since you've got two of these, like it has to be there and there. So derivative of the outer leaving the inner alone, and then we multiply by the derivative of the inner. Does that make sense? So like the chain rule is probably, well, I don't know, but the chain rule is like a super important derivative rule because all of the other derivative rules essentially were just giving us a means to take the derivative of an outer function when the outer function was secant, when the outer function was inverse sine, etc., etc. This can be simplified here. The e to the power of x to the 1/2 is the square, yeah. We're going to write the square root as the 1/2. So it's e to the x squared to the power of 1/2. And what do we do there?
You can just multiply the squares, right?
Yeah, you can multiply the exponents, right? E to the x squared, 2 times 1/2 just gives us e to the x. Or we could have simplified algebraically first and said, well, that's e to the x squared. Isn't the square root of e to the x squared just e to the x? But at least just writing this out, we can see, you know, how that applies to like more complicated pieces. Okay. So I don't know. Does that make sense? Y'all have questions or comments about that? If you know the derivative of all these functions and the chain rule, you can take the derivative of any function, regardless of what it looks like or how complicated it is. So the, just to mention right last, the, finding the x values where a function has a horizontal tangent line. We did a couple of those in class, not a whole lot, but the process for a horizontal tangent line is you find the derivative, you solve the derivative when it's equal to 0, and that gives you the x value. It's at that x value you have a horizontal tangent. So we did some of those in class. The given a population function, find the steady state population, and some other stuff. The steady state population is the limit at infinity on the population function, so make sure you remember that. a lot of people will want to take the limit at infinity on the p prime, but that's not what steady state population means. Population. Yeah, and then when I say you're given the graphs, match their derivatives, or wherever that's at. Match the function with its derivative. So again, you'll have a graph like on this side. Here's the function, and some other ones. You'll have, like 3 or 4 or 5 or whatever. And then on the other side, the other column would be like, here's this thing. You have to say, oh, hey, this function matches with that derivative. So I'm not going to say, hey, here's a function, graph by hand the derivative. You're just going to match them. Okay, I think, that's all I really wanted to mention. If y'all have other questions, then we can continue looking at them.
Could we do another problem with the chain rule?
So those are involved. I mean, the one we did here, the sine squared of e to the 3x. Oh, we did -1. They have +1. Doesn't matter. But there might be 1 or 2 of those on there. 2 at most. The other chain rules are going to be more, or I guess less involved. So like, chain rules for like sine of 5th to the x, sine of x to the 5th. Those are a lot more common than having to do 3 or 4 chain rules. So, do you want to keep looking at these multiple chain rules, or do you just want to look at multiple chain rules?
There's an option.
Yeah.
I don't know. That surprised me. I guess.
Okay. I'll just cheat here. We've seen sine a lot. So we'll look at tangent 5th of x, and we'll look at tangent of x to the 5th. So this one here, again, this is the quantity tangent x raised to the 5th power. The one on the right is, it's the tangent of x to the 5th. Similar, totally different. So like if I'm taking the derivative of tangent x all to the 5th, then my outer function is the 5th power. So I'm going to say the derivative of the outer function, leaving the inner alone, and then multiplying by the derivative of the inner. It's all like here, Okay, my inner function that I left alone was tangent. idea. So what we have then is 5 tangent to the 4th. And we can just write this one like that. I don't know who decided that was a good idea. The power's there. So it is. Times the derivative of tangent, which would be what?
Secant squared.
Secant squared, yeah. So it's just secant squared. So that's our derivative there. Again, on the exam, just write that. Don't try to solve for anything. If it just says find the derivative, and leave it at that. I wouldn't say simplify this. Probably simplify it by writing in terms of sine and cosine. There might be identities you could use, right? There's a lot of ways to simplify trig functions. So most of those derivatives on the exam, unless it's like really basic simplification, I would just have you leave like that. Okay, and then if we compare that to this derivative, now the outer function is tangent. So we say the derivative here of the outer function, leaving the inner function alone, derivative of tangent is secant squared. But we're leaving the inner function alone, and we're multiplying by the derivative of the inner function. So that should look like that, secant squared of the quantity x to the 5th, all of that times the derivative of x to the 5th. So that's just that. I don't know if that's helpful. There's
That was.
there's so many functions, right? Like you can put square roots and all of that, exponentials and all of that. There's a ton of derivative rules. So yeah, just be on the lookout for further communication / emails through D2L. But like I said, really the day-to-day doesn't change much. You still want to keep up with your homework. You still want to do your quizzes. The day of the exam is when all that stuff's going to be due still. None of that has changed. Instead of coming to class to listen to me babble on for 2 hours, you're going to just watch it on YouTube. The notes are going to be posted. You can fill them out as you go. Okay, we'll figure out the exam. I'll let y'all know as soon as I can. In the meantime, email me with any questions you have, and I'll get back to you.
Well, nice meeting you, man.